PareTOWorks is an add-in tool to SolidWorks for carrying out topology optimization. We start with the setup, and then we initialize the part. We can pick different units, material properties, and here are the specific material properties: Young's modulus, Poisson's ratio, density, and so on. And then initialize that. You'll also get a prompt window where you can see the update or the progress of topology optimization. We can close the window for now, and then we can apply the boundary conditions. The boundary conditions for this simple example, we're going to fix this part, fix this face, apply, fix this face again, apply, and finally we can apply a load in the y direction, downward force, so negative y. So we're going to say force, negative y, and this will be in newtons because we use the SI units. Say apply. Next, we are ready to carry out meshing, and we're going to use a coarse mesh with about 5,000 elements. Mesh, we're done. We don't see the mesh right now. We can see that in the static finite element analysis. We carry out a static FEA. What we see here is the displacement and stresses, and you can see the maximum deflection, and this is in meters, and this is in newtons per meter squared, and that's the overall FEA results. Finally, we are ready for optimization, topology optimization. We can either optimize with respect to compliance or stress. I'm just going to go with compliance, minimize compliance, in other words, maximize stiffness, with a target volume fraction of 0.6, which means remove 40% of the material. And here's a constraint that says make sure the stress as you optimize the topology doesn't exceed twice the current stress. Whatever stress we saw a minute ago, don't exceed twice that value. We can change that if you like. And this option simply says retain these faces during optimization. So we start the optimization process. And in fact, we can watch the progress in the DOS window. And we are done. As you can see, the optimization was completed using 25 finite element operations in 4.3 seconds on my desktop. Say OK, and we get this final topology. This is an STL model, and you can save that in the STL format. And we're done. So that's a simple example of topology optimization carried out within SolidWorks.